Okay, here we go now, diving into quadratic functions and graphs. Today, quadratic equations and inequalities next time. And this is where we're going to start to see why we had to learn about complex numbers. Okay, so what is a quadratic function? Quadratic function is a function defined as such. P of x, in this case p is just the name of the function, so that's a function notation. P of x equals ax squared plus bx plus c, with a definitely not 0. So in other words, you have to have that ax squared term. A, b, and c are just generic, real numbers. But you have to have that x squared term in there in order for it to be a quadratic function. The x term and the constant term can be there or not be there, but the x squared term is necessary for it to be a quadratic function. If you take out the x squared term, then you got bx plus c, which is a linear function. So that's the difference there. And that's it. That's, you have an x squared, an x, and a constant, and that would be at most what you would have in this function. So how could it look? Well, let's put a couple in a calculator and you can see what they might look like. So I'll go to y equals, you could put in 2x and then squared plus 3x minus 7. That's an example of a quadratic function. And as soon as you hit graph, you'll see it being graphed. This is a parabola. So your quadratic functions, when they get graphed, are going to be parabolas. This particular parabola, it looks like a cup that would hold water. You go back to your y equals. The number in front of x squared, your a, tells you whether it's going to hold water or dump out water. If a is positive, it'll be a cup that holds water. If a is negative, it'll be a cup that's dumping out water. So let me put one in where a is negative and show you what that looks like. So let's say we have negative 3x squared plus 2. And I'll just show you, you don't have to have the x term to see it. But there it is. So that one that's dumping out water is y2. Well, we just typed in the y equals menu. So that's examples of quadratic functions. Now the form that I was just typing into the calculators, that is a standard form. The standard form is great. It tells you it's a quadratic function and you can actually get a lot from it. But sometimes it's necessary to change that standard form into a different form by a process called completing the square. And once we complete the square, we can end up with a form that can very quickly tell us some vital information for graphing a quadratic function, including whether it's cupped up or cupped down, which you can already see by A, also what the vertex should be in the line of symmetry. Because a parabola is symmetric. The kinds of quadratic functions we're graphing right now are parabolas either cupped up or cupped down, concave up, concave down, and they have a vertical axis of symmetry. So being able to determine all of that information can help you with graphing. And here's the steps for how to complete the square. Here's this, if you want to take notes of the steps, this slide is it. And these are the steps that I'm going to follow on the following slides when I do some completing the square. Okay, so let me switch to my pen. It automatically puts it in red now. I don't know why it does that. Okay, I must have it default red for some reason. Let's start with function f of x equals x squared plus 6x plus 5. Okay, so there's our quadratic function. In this one, the a is 1. The a is the coefficient in front of x squared. B is 6, because plus 6 is in front of x. And then c is 5, because plus 5 is the constant over here. All right, and in order to complete the square, one of the first things we want to do is check on a. If a is 1, we don't need to do any dividing. But if a is some other number here, we want to divide the entire function by whatever that number is. So we don't need to because a is 1. Then our next step is to get the x squared and x terms by themselves on this side So we're going to subtract 5 from both sides. 5 will go back later, but for now we're kind of scooting it over and getting it out of the way. Okay. Then we take b, which is 6. It's actually going to be b over a because you divide through by a, which in this case is 1. So you take that 6 there, you divide it in half, and then square the result. Oops, sorry, square the result. I was thinking ahead to what I'm going to get. So you have 3 squared, which is 9. And when you do that, whatever your result is, you're going to add that to both sides of your function. You're allowed to add or subtract anything you want to an equation, which this is an equation, has an equal sign, but as long as you do the same thing on both sides to keep it balanced. So I'm adding 9 to both sides. And the reason I'm doing this is because I'm trying to turn the right side into a perfect square trinomial. I'm completing this square here, turning this into a perfect square trinomial. So the words completing the square literally come from trying to make a square complete. X squared plus 6x plus 9. You have a section that's x by x. That's your x squared. Then you have your 6. 6 times x is 6x. I'm sorry, not 6. You have to do 3. Erase that. Sorry, not 6. 3. Haha. Phew. And this is 3. So you have x squared plus 3x plus 3x, and you literally want to complete the square right here. So you have 3 times 3, or 9. And then all this added together makes a square. X plus 3 times x plus 3. X squared plus 6x plus 9. So you completed that square. And it's handy to do that because now on the right side there you can factor. It's a perfect square trinomial, so you can factor it like such. X plus 3 quantity squared. Yeah, x plus 3 times x plus 3. Okay, it's almost done. Once you've factored that right side, this plus 4 now can be subtracted from both sides, and you can get f of x by itself. And now you have a different form for that same equation, of that function. So these two, whether either one, you put either one in your calculator, you're going to get the same exact parabola. It's just you've completed the square and changed the form. And the lovely thing about this new form is it reveals a lot of information about the graph. This new form, in this new form, it fits the f of x equals a times x minus h squared plus k format, where h and k are your vertex and a tells you whether it's cupped up or down or whatever. We already know a is 1, so a is greater than 0, so that tells us it's going to hold water. And then, okay, f of x equals x plus 3. Well, in the format, we can write that as x minus negative 3. So h is negative 3, because we need it in the form x minus h. And then plus k, so minus 4 is the same thing as plus a negative 4. So k is negative 4. So the vertex of this parabola is at negative 3, negative 4. Okay, let's put it into the calculator and look at it. X squared plus 6x plus 5. X squared plus 6x plus 5. You hit graph. Ta-da. -3, 1, 2, 3, -4, 1, 2, 3, 4. Here's the vertex. And as we thought, it's cupped up. It's concave up, means it's going to hold water. Yay. So that tells us a little bit about that function. All right, let's do one more of those so you can see another completing the square example. Let's take f of x equals -2x squared minus 12x minus 16. And let's complete the square on that. In this one, the a is -2, which already, since a is less than 0, that tells me the parabola is going to not hold water. It's going to dump it out. Our b is -12. Our c is -16. All right, we want to get this from standard form into the form that gives us the vertex. Okay, and so in this case, since a isn't 1, our first step is to divide both sides of this function by a, by -2. So we're going to have f of x over -2 equals x squared plus 6x plus 8. Makes things a lot easier when you go to try to complete the square. Okay, then this right side is not a perfect square trinomial right now, so we can't factor it. It would be nice if we could, but we can't. So we need to take this plus 8 and subtract that from both sides. And that'll leave x squared and plus 6x by themselves over here. And now we're set up to try to complete the square. We take this number that's in front of x, we take half of that, and we square it. So half of 6 is 3, squared is 9, and that's what we're going to add to both sides of the function. Okay, so we've got f of x over -2 plus 1 equals, then x squared plus 6x plus 9 will factor into x plus 3 quantity squared. Okay. Then start getting f of x by itself. What we're going to do first is subtract that 1 from both sides. That. Then we're going to multiply both sides by that -2. Now distribute your -2. So you have -2 times the x plus 3 squared, and the -2 times the -1, which would mean plus 2. And there you have it. A is still -2. That's not going to change. So we still know that it's cupped down, just dumping out water. And then the vertex is h comma k. Remember, we got the format has to be f of x equals a times x minus h squared plus k. So whatever the sign is inside here in the parentheses, you're going to use the opposite of that for the vertex, the x coordinate. So if it's plus 3, you're going to use -3. And since it's plus k, whatever signs out here for this number is the same, so +2 for that vertex. So -3, 2. So let's put that one into the calculator. I'm going to go ahead and put the original function in just to show you that you do end up with the same vertex and everything. So we're going to put in the -2x squared minus 12x. So -2x squared minus 12x, and it was -16. So we hit graph. There it is. We see it's cut down. And remember the vertex we found was -3, 2. Well, 1, 2, 3 to the left, 1, 2 up. There's your vertex right there. That single point at the very top of your parabola there. So. So that's a little bit of completing the square. So once you've completed the process of completing the square, you've got this format. Now we know about the vertex. Now we know about cupping. And we can use that. And if we want to, we can graph by hand. We can graph that vertex. And then wherever the vertex is, there's a nice axis of symmetry. The x coordinate of the vertex, you can say x equals that number. That'll be a line of symmetry for your parabola. You can plot a point to either the right or left of that line of symmetry and then just reflect across, mirror image, and get another point. So really, you only need to figure out half the points of a parabola because you can reflect those to get the other half and then connect the dots, make a nice smooth curve. So let's go ahead and do that. Starting with f of x equals x squared plus 6x plus 5. That was the first one that we completed the square on. We did that when we completed the square. We got x plus 3 quantities squared minus 4. Vertex was -3 comma -4. And we know that this one is going to hold water. Okay, so we can plot -3, 1, 2, 3, -4, 1, 2, 3, 4 right here. And then since that's the vertex, we know there's going to be a line of symmetry, a vertical line of symmetry running through that vertex. So we just need to pick some points on one side and then we can reflect them over to the other side. So let's do this. Let's first try putting in -2 for x. If I put -2 in for x, -2 plus 3 is 1, 1 squared is 1, minus 4 is -3. So -2, 1, 2, -3. Well, once I know that -2, -3 is a point, I also know that -4, -3 is going to be a point. Because I can reflect across this line of symmetry here. If from this line I go 1 to the right, then I can also go 1 to the left from that line and get another point. Okay, plug in -1 for x. -1 plus 3 is 2. 2 squared is 4. 4 minus 4 is 0. Ooh, x-intercept. I know -1, 0 is an x-intercept. Okay. This invisible line of symmetry, okay, that was 2 to the right, so then from there go 2 to the left. And I see that -5, 0 is also on there. So from figuring out -2, -3, I also know that -4, -3 is on there. Figuring out -1, 0, I also know that -5, 0 is on there. And just one more. How about we do, let's do the y-intercept. Plug in 0. 0 plus 3 is 3. 3 squared is 9. 9 minus 4 is 5. So I see the y-intercept is at 0, 5. Right here. Here's that line of symmetry. It's 1, 2, 3 to the right of that. So I got to go 1, 2, 3 to the left. I get the point -6 comma 5. That's probably plenty of points. You only need maybe 5 points right here to really get a good idea of the shape. You can do more if you want. But I find that the vertex plus maybe 4 more points like this, the way I did it, is usually enough to get a good idea of the shape. But it can be fun to get more. The more points you have, the more accurate your shape will be when you connect your dots. Smoother you'll be able to make it. But there it is. There's the parabola that has the function f of x equals x squared plus 6x plus 5, or you could also say it has the function f of x equals x plus 3 squared minus 4. So either way. Okay, and let's do the other one too. Let's do the f of x equals -2x squared minus 12x minus 16, which when we completed the square, we figured out that f of x equals negative 2 times x plus 3 squared plus 2. So vertex was negative 3 comma 2. And since a is negative 2, a is less than 0, that tells us the parabola does not hold water. It tells us it's shaped like that. It tells us the vertex is going to be at the tippy top here. Okay, so negative 3 comma 2. 1, 2, 3, 1, 2. We're right here. Okay, so for our xy table, let's put in negative 2. Negative 2 plus 3 is 1 squared. Negative 2 plus 2 is 0. Ooh, our x-intercepts. Ah, dang it. Okay, so let's do that again. Negative 2 comma 0 right here. Then also think about that line of symmetry. I know I'm going to have this point here. Negative 4 comma 0. And then let's plug in negative 1. Negative 1 plus 3 is 2, 4, negative 8, negative 6. And then line of symmetry. I also know that I can go over here at another point. Negative 5, negative 6. And there you go. There's that parabola. Now, if you look at it closely too, the second form tells you a lot about shifting and so forth. Let's go back to this one first. Let me change the color of my pen. Let's say you started with f of x equals x squared. Okay, you have f of x equals x plus 3 squared minus 4. The f of x equals x plus 3 squared, that part tells you that you're shifting to the left or right, and because it's in the parentheses, the plus 3 is in the parentheses being directly added to the x. So that tells us you're shifting left 3. So let me change my color. So then shifting left 3, you've got, oh, where'd my pen go? I can't see it now. Maybe that orange color wasn't so good. There we go. Shifting left 3, so everything moves over 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. So look, you can also use your shifting rules that you learned previously and get here too. So I went through earlier and showed you vertex and plotting points, picking and plotting points. But if you're more comfortable using shifting rules, you can also use those and get your graph. This is parabola. Okay, we shifted left 3, and then the minus 4 tells us we got to shift down 4. So minus 4, you were taking this here, going down 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, etc. So then this black one, f of x, is x plus 3 squared minus 4. So there's all your rules. So you can either find your vertex and do an xy table and get your parabola that way, Or you can start with your f of x equals x squared and use your rules of shifting, reflecting, shrinking, stretching, etc. too. Well, this one as well. Once it's in this a times x minus h squared plus k format, you can see, first of all right, our function must have been shifted left 3, 1, 2, 3. Then you've got this -2, which tells you you're reflecting across the x-axis and stretching by a factor of 2. So it ended up down here. And then this +2 is telling you then you're shifting up 2. So you'd end up with this particular graph. So that's still, those rules still apply too. It's totally up to you how you want to graph them. If it doesn't say how to graph it, then you can choose which one you like better. Whether you want to start with the f of x equals x squared and follow the shifting, reflecting, stretching, shrinking rules, or whether you want to identify vertex and some xy coordinates and then connect the dots. Okay, and here's yet another way to try to find some information. I'm showing you lots of different things. Maybe you can pick and choose what's going to work best for you, but be familiar with all of them. The vertex formula offers a shortcut for finding your coordinates of your vertex when you're in standard form of your quadratic equation. Basically, the x-coordinate is negative version of b over 2 times a, and then whatever you get for that, you can plug in for x to see what the y-coordinate would be. Okay, so going back to our first function, f of x equals x squared plus 6x plus 5. That's in the standard form. A is 1, b is 6, c is 5. Okay, now remember the vertex formula said the x-coordinate is negative b over 2a. So negative b, negative 6 over 2 times 1. So negative 6 over 2, which is negative 3. So that's the x-coordinate of the vertex. And then to find the y-coordinate, you evaluate the function f at negative 3. So you get 9 minus 18 plus 5. So negative 9 plus 5, which is negative 4. So that tells us that our vertex is at negative 3, negative 4. Doesn't surprise me. So if I go back a little bit here, my vertex was negative 3, negative 4. Okay. And then I'll do the next one. The vertex had been at negative 3, comma 2. So let's apply the vertex formula and get that same result. So just another way to find your vertex. Okay, so the x will be negative b over 2a. So in this case, you got a negative negative because it's negative b, and b is also negative. So it's opposite of b. So 12 over 2 times negative 2, or negative 4, which is going to give you negative 3. Then you evaluate the function at negative 3. So you've got negative 2 times 9, which is negative 18. Minus 12 times minus 3 will give you plus 36. Then you got minus 16. Well, negative 18 plus 36 is 18. Minus 16 is 2. So your vertex is negative 3, comma 2. I don't know why my pen did that. Let me erase that extra little 1 there. It's not supposed to be there. There you go. So vertex negative 3, 2. So you can see from vertex formula, you get the same thing. Just like we did there, negative 3, 2. All right, one last thing, more on the vertex. Vertex is something called an extreme point. singular extremum, plural extrema, and it's on the graph of the parabola. If the parabola is concave up, holding water, the vertex is the minimum point, and the y-coordinate is considered to be your minimum value on the graph. If the parabola is concave down, the vertex is the maximum point, and the y-coordinate is the maximum value on the graph. Okay, let us go ahead and pull up the calculator again and take a look at this. Okay, so for our first, well, for that second function, f of x equals negative 2x squared minus 12x minus 16, I already have it in there. I already have it graphed. You can see the parabola, the vertex at negative 3, 2 right here is one of those extreme points. It's a maximum. And then you can use your calculator to figure out what's going on there. Since it is a maximum, you can use you can go to second trace, which is the calc menu, go to number 4, left bound, trying to figure out where exactly there it is. Make sure you just connect to the left of that point. Then for right bound, use your arrows, left and right arrows, move to the right of that point, and then guess, enter, and then there it goes. It gives you, well, negative 2.99999. It's negative 3. Just calculators have a numerical way of computing things, and sometimes they're a little off. But there you go. And the maximum value on that function is the 2, the y-coordinate. And if you want to do the one, the x squared plus 6x plus 5, go ahead and graph that one. Then for that one, the vertex is a minimum point. So then when you calculate, you want to use number 3 for minimum. Make sure you go to the left of that vertex, hit enter, go to the right of that vertex, hit enter. Oops, what is it doing? Left bound. I'll do it. For some reason it didn't acknowledge my enter. All right, something's wrong with my keyboard there. All right, right bound. Enter. Enter to guess. Okay, negative 3 comma negative 4. So the minimum value for that function is negative 4. And it's located at x equals negative 3. So there you go. So a little bit about maximum minimum values, which will be helpful when you're trying to do some of the word problems, and also a little bit on how to use your calculator to compute that stuff. All right, so we'll dive more into this next lesson. We're not only worrying about minimums and maximums, we're going to start worrying too about where this parabola intersects the x-axis. As the y-axis is, we don't know where it intersects the y-axis too, but next lesson is going to really focus on these x-axis intersections, being able to determine what they are and being able to use information from those to figure out things about inequalities. So there you go. So I hope you enjoy, and I will see you next time for more quadratics.